Hello, everyone. Thanks a lot for joining and welcome to today's webinar on designing wireless networks for stadiums. So, very hot topic now with the European Championship in soccer coming up, well, starting now, and the Olympic Games coming up. So, we're definitely very excited to host this event, and we're hosting it with our special guest, STF Gruppe. You might already know them since we did a few webinars together last year and this year. So STF Gruppe is a system integrator, one of the leading ones in Europe. They do a lot of campus networks and in-building projects, everything from private networks for industrial to stadiums, metro. So definitely look them up. They do a lot of cool things. And I would just like to quickly introduce myself and our speakers. My name is Daniel Sternat. I'm the product marketing manager at IBWave, and I would like to welcome our guest speaker, Viktor Piachev, who is our network design engineer at STF Gruppe. Welcome, Viktor, and thanks a lot for joining.
Hello, Daniel. Thank you. Nice to be here.
Thank you. And also, of course, Ralph Burkhardt, our sales engineer from IBWave. Welcome, Ralph.
Yeah, welcome, everyone. Thanks, Daniel.
All right. So just before we get started, I would like to cover a few housekeeping items. So as always, we will record this webinar and you will receive the recording in your email within the next few days. And I would also like to encourage you to ask questions, and you can do so by using the side panel of GoToWebinar, and we'll answer these questions at the end of the session. And lastly, if you have any follow-up questions or you would like to request pricing or private demo, please contact sales@ibwave.com and we'll make sure to get back to you as soon as possible. So that's all from me for now, and I'm going to hand it over to Ralph. Enjoy.
Yeah, thanks, Daniel. So my name is Ralph Burkhardt. I'm based in Germany and happy to host this webinar today. And hi, Victor. Great to have you here as well. I'm with IBWave now since more than 9 years, and really happy to host not only the webinar, but as well to have the European Championship here in Germany. And I think we had a really good start on last Friday with the German team against Scotland. So very promising. So I hope everyone is enjoying the championship and the hot topic we have today about the software behind wireless networks in stadiums. So the question is, who's IBWave? IBWave, if you don't know, that's the worldwide standard for in-building design, survey, and documentation. So we have a complete solution really for every phase of a design, survey, and installation part. So at the end, you will get a digital twin of your network in one IBWave project file containing all the information you need. We are trusted by more than 1,000 customers worldwide in more than 100 countries. So this webinar is not about, it's mainly about cellular. It's not about Wi-Fi. We have hosted a lot of very interesting webinars, great webinars from Vladan here, as you can see on our website. So have a look at these. If you go to our blog, ibwave.blog.com, you will get as well a lot of very, very useful information about stadium design. So have a look at these if you're interested in more detailed information about stadium design we have done in the past. IBWave has supported all the major sport events since many, many years. You know, IBWave is there in the market since 20 years. And I mean, the latest one is the UEFA Euro Championship just now. There will be upcoming ones like the Olympics in France. We support as well all the athletics, rugby, cricket, all these kind of different sport venues. And I've chosen some of the testimonials we have, and I've chosen this one from 2014 simply because Germany was there and won the championship. And since then, we were not very successful. So I hope that this year for the European Championship, we will get one of the medals again. And the Olympics, it's all about saving time and cost and get the best network design with our solution. Okay, so fan experience. I think that's the most important topic at the moment for everyone, because everybody is talking about augmented reality and getting statistics and all that stuff. So it's really important to have a public 5G network which gives you the coverage outside and inside the stadium, so that you're able to do streaming, social media, and get access to all the digital content as well. Private 5G networks will give you some more benefits to it. You can get really the bandwidth, because for private 5G networks, you have a dedicated frequency band, which allows you to have more data transmitted. Like in millimeter wave band, you will get like 400 megahertz of bandwidth, which allows you to do a lot on augmented reality, statistics, instant replay, and all that stuff. But on top of that, it's not only the fan experience, it's the operational efficiency, which you can get by the private 5G network, because all the IoT in your stadium, like lighting, security systems, and all that, can run on IoT. And that's another important topic. So both together, the hybrid, we call it a hybrid network, which combines public and private 5G network all in one solution, gives you the best performance at the end. So there's some examples, like you have this. You will find a lot of examples there in the internet about applications, multimedia applications for stadium specifically. If you look at some specific ones, like this one from Vodafone, but every operator has the same. It gives you very, very detailed information, statistics in real time, which you might not get from a big screen on the phone. Yeah, so this is really, I think, the big differentiator, getting this information in real time. Okay, so what are the challenges if you upgrade to new technology in a stadium? There is an existing system already. All the stadiums have existing systems like a 4G network or Wi-Fi network, and adding a new technology is not only a complex, some process. In some cases, it's really difficult, because you need to have space for the maybe new antennas if you can't replace them, things like that. So it's a complex process, and you have to ensure that the existing system is still performing well. At the end, you have added just a new system and the old one, because not everyone is on a 5G phone. People are still on 4G. You need to support that technology as well, and it has to perform. Setting up new technologies always increases the cost, because you have to install new equipment, antennas, you have to upgrade existing equipment from maybe 4G to 5G, and if you add IoT devices, you will get your stadium fully connected, but that always involves additional cost. So therefore, an accurate network design is really, really crucial for the improved fan experience and for the operational efficiency. At the end, you don't want to over-dimension your network, increase too much cost on CapEx and OpEx side, but if you under-dimension it, you will not get the fan experience and the performance you expect from that. Okay, so what is typically the best practices, challenges when you start with a network design for a stadium? The stadium itself, that's more than just a bowl or the playing field. So you have the stadium with the bowl, you have maybe roads and tunnels which are there. There might be car parks outside somewhere. You have train connections to the stadium, and overall the people are outside as well before they enter the stadium. So you have to make sure that they get enough coverage, they get access to all the services, and they get the fan experience you expect. Minimize the interference. That's one of the design criteria, the first one you should take care. It's the indoor system which you design, and that should be the best server inside the stadium. How you do that with sectorization, antennas, that's the topic of today's webinar. And Victor will go into detail of that. The IBF design solution allows you to do a proper and accurate and network design for the indoor part. The outdoor part, it's the macro network, the existing one. That will create, this coverage will leak into the stadium into the building as well. Yeah? So there's coverage which you could measure with our IBWave mobile survey application and import that interference into your network design. But you could as well use our IBWave Reach macro network planning tool to simulate the macro predictions, import that into the IBWave design tool, and run all the interference simulations to make sure you have the best performance of the network. Okay, so minimize interference. That's really, really important. The other thing is make sure that you identify all the key areas. I mean, there are always VIP areas, there are shopping areas around. You need to have dedicated maybe coverage in these areas. You need to make sure that they have enough throughput. Yeah, so it's capacity you have to design as well in specific locations. So it's not just the bowl, and there will be hotspots where you have to take care about. And for these, you need to define the required capacity. And capacity at the end, this is the number of radio sectors. Yeah? But again, you need to minimize the interference to get your optimum capacity. And this again is not overdimensionate or underdimensionate. It's really, really important to do a proper radio network planning. And Victor will show you how that works. Sectorization, important, because now we are inside the stadium, and there are different ways to do the sectorization. Yeah? You can do it as a ring structure, as a wedge structure, or do it hybrid. So you can really sectorize the seating areas sector by sector, and then you try to optimize it so that you don't get too much interference between the sectors. But how do you achieve these sectors? If you look at normally antenna, for example, normally antenna that could create too much leakage to the outside, which you don't want. It might not have a well-defined border for your sectorization. And you could, for example, you could go there and say, okay, I'm reducing the power of the antenna so that it does not have so much leakage. But again, you will get problems. Maybe you don't cover enough of the required area. So a normally antenna is in most of the cases not the right solution. We are looking for directional antennas if you go for stadium design. And a directional antenna will give you a defined coverage area, and the leakage to the outside, because of the antenna direction, will point to the area where you need it. You will get the best performance. Okay, but if you use these type of antennas, it is important that you have an accurate modeled antenna pattern as well. And in this case, because we support really 3D antenna patterns, which allows you to use measured antenna patterns where you can see not only the main beam, but you see the side lobes and you see the back lobes. And this is really important when you run fast ray tracing predictions to get the best performance of the network and minimize, again, interference. That's it. You could use specific antennas like these handrail antennas used to be closer to the spectators, to define the area better, more accurate. But you could go as well, if that is possible, you could go for radiating cables. That's another option. So you can just use radiating cable under the seat, close to the seats, with very low power, and make sure that you get enough coverage in a very, very defined area, not interfering other areas. So if you look at that example, that will probably give you the one option if, for example, sectorized antennas are not possible, because there are many cases where you're not allowed to install an antenna. Maybe that is an option which you could use as well. So the design fundamentals, and that's the topic of today's webinar. Victor will talk a lot about the signal strengths, the interference, and the data rate, because that belongs together. If your signal to noise interference ratio is not performing, I mean, you will not get your data rate you want to achieve. So signal to noise is always important to get the data rate. And this is one of the design fundamentals. So why using the IBWave design for that? There are a lot of features and benefits specifically for stadiums. One is the advanced 3D modeling of all the inclined surfaces you have in design, the body loss configuration modeling, so you can assign people in the sitting areas, you can assign people in standing areas with different body loss, because every body adds loss to the signal, and you can really do accurate simulations. We have a stencil library where you can add as any component, any structure. Could be the catwalks, could be the seating areas, could be, like in this example, cars and trees and things like that. All of them you can store in a library and just drag and drop to your project. Saves a lot of time and increases the accuracy at the end. And accuracy, fast and accurate predictions, that's important. And we support NVIDIA, CUDA graphic cards for very, very fast network design. Indoor and outdoor, as mentioned, you can see that there's an open roof, so there's signal coming from the outdoor to the inside. This is important as well to consider. We do have the IBWave Reach solution for that, and here you can find as well on our website lots of content and webinars on our IBWave Reach solution. Will be not part of today. We will just have a quick look at that. Detailed capacity analysis. As I said, that's important because you will spread all your users across the different floors of the stadium, and maybe you will have hotspots with dedicated number of users, and in each of these hotspots and areas, they will have a different user subscriber profile, the streaming and all that stuff. And you can define that in very, very detail and run your simulations. It should be future-proof. We support IoT, millimeter wave bands, all the technologies, all in the same project file. And most important is you will get dedicated stadium training program on our IBWave Wave Runner platform. So as a conclusion, and before I hand over to Victor, stadiums are really high-profile venues. They generate revenues. That's clear. Stadiums are one of the most challenging environments to design for. Why? It's very complex. You are limited in antenna positions. There are a lot of people in the stadium, and you need to provide capacity and minimize interference. And therefore, it's really important to have a proper radio network design to get that fan experience and operational efficiencies. At the end, that's the return of invest for that stadium project. And here I would like to hand over to Victor to go really in practical network design topics. And the floor is yours, Victor.
Yeah, thank you very much, Ralph. I think you gave me lots of credits. I will need to give them back. Yeah. And first, if you can allow me to share the screen. Can you see my screen now? Welcome everyone on the bridge again. Can you hear me? Just send a plus in the chat.
Yes, I can see you, I can hear you. If you make it in full screen, that would be perfect.
Okay, right. So thanks a lot. I really enjoyed the slides you have shown. I guess this design based on radiating feeder, actually, it's a really interesting one. Maybe you don't have any problem with antenna selection, right, Ralph? So it's simply the feeder, and that's it.
That would, just in case you can't mount antennas at the positions where you want, you could use these radiating cables. You could use under-seat antennas. That's something as well, which I've seen in real implementations. Yeah. That's all possible, and it's case by case. Every stadium is different, so you need just to find the right solution.
Exactly, especially when you don't have a roof. Yeah, maybe this is a solution. So let's go straight to the topic. I'm Victor Piachev. I work this August will be 4 years. I work for company STF Gruppe. I'm based in Berlin. STF Gruppe, we are working with mobile network operators. We're supporting them to plan radio networks, to plan indoor campus networks, and so on. As far as I know, we operate also in Switzerland. And today my content would be about practical challenges, what we see, less maybe future, more practice. Yeah. So some experts say that if you can plan, or somebody can plan a radio network for the stadium, you can plan at all whatever you want. So you can plan most difficult networks, outdoor, indoor, based on the moon. So it doesn't matter. It is really the challenge. And actually, I was thinking how to start, maybe to just to read the agenda.
Just to mention there, if you look for, if you search for that, you will find a lot of 5G networks already planned on the moon. Yeah.
By the way, yeah. And my agenda actually, it is. I hope it is readable here. But I wanted to start with a small, short story. One of my friends, he decided to visit Metallica concert here, and not far away from Berlin. Yeah. And actually, I asked him if he can connect to the network just 10 minutes before the event would be started. Yeah. And actually here on the left side of this screen, this is the result. So which means the problem is actual. Yeah, it can happen. So when you cannot even connect, of course, in this case, it could be just PDCCA channel problem, some overload on PDCCA channel. But in general, there is a big problemacy with football and all other types of stadiums. And today I would like to give you one example with football arena and one example with hockey arena. Which one would be more difficult to plan, do you think, Ralph? Football or hockey?
I think both are, because it depends on case by case. Each stadium is different, so it does not depend on which type of sports it is at the end.
Yeah, so yeah, correct. I will try to start with this with explanation of this curve on the right side. Maybe for those who have been working already with stadium planning, this curve would be already more or less recognized. But what happens here? Let's try to perform some virtual experiment. For example, we have a stadium, maybe x6,000 users, yeah, and we would like to have network there. So what do we do? Of course, one cell probably will be overloaded. So we are starting to add cells one by one. So this part of the chart, I hope you see my mouse, this is so-called linear part. You are adding your sectors and you are getting your capacity also in linear way. But at some point, you start to have the situation when you add more cells. For example, you have calculated those cells through capacity calculator, and it shows that you need to deploy, I don't know, 65 cells or so. And if you would attempt to deploy so many cells, you would observe that network capacity starting to be not that linear anymore, and this is declination. And at some point, you will be on the peak. And if, for example, if you're not aware that it would be a peak here, and you would continue adding your cells for your, let's say, imaginary stadium, you may observe very negative effect, which would be described as network capacity would be now lower. Of course, for those of you who have planned with millimeter wave, such a curve may be, let's say, this peak would be really hard to achieve. However, if we talk about LTE 1.8, 2.1, 2.6, all of this, let's say LTE and /5G stuff we like to work with, yeah, this peak is really can be, let's say, predicted. So, and our attempt was to define this peak with the instrument which we have for planning, which is IBWave, yeah. So, and also quite importantly here, I mentioned this, let's say, when you cannot connect, such situation can exist for a very short period of time, like 5 minutes, 10 minutes, 15 minutes. And in the end, in the statistics, you may not even observe it was any kind of issue because you are observing, like, say, 1 hour counters, you do not observe issue there, but within 15 minutes interval, it can be problematic. Ralph, would you prefer to be in over-dimensioning part if you plan, or would you prefer to be in under-dimensioning part if you plan your stadium? Could you please tell me?
I mean, that's a good question, yeah, because if I'm under-dimensioning, it means that I'm not offering the performance I expect to the audience. And if I over-dimension it means if I trust your curve, it means that I'm degrading my system performance, and which means I spend more money and get less, yeah, which does not make sense for me. So according to the curve, if that is true, I would say be in the optimum area. But how do you get there? That's a big question. Yeah,
yeah, that's a question, how you do get there. And of course, I would also prefer to be on the optimum. And overall, I will try to explain this effect with some visualizations. Of course, I would also prefer, if to choose between under and over dimensioning, it's even a little bit better to be underdimensioned because you have still opportunity to increase cells. But what is more important, in every cell, it is still achievable for you conditions for high order modulations, which means you can still achieve very good SNR. If the network is appeared in this zone, over dimensioning area, yeah, so your maximum SNR can be limited already. And this is quite dangerous because, of course, if there is a WAN stadium, it's a lot of features of vendor, and they are working with CQI, good SNR, 256 QAM modulation, everything, all of this would need really good radio conditions. But in this part, on the right side of the graph, this would be already unachievable. So it's quite important to know where is the peak. And I may imagine that this character of the curve is known for almost for everyone who is doing really planning. What is possibly what is less known, where you are located at this moment, where you are located. Are you located on the peak? Are you located right side, left side, and so on? Yes, the mechanism, yeah, good, GIF is working today. the mechanism, how this curve can be explained, yeah. So, of course, explanation of this declination of the capacity is due to intercell interference. So we have always unwanted signal. For example, we are trying to cover only one part and our footprint is expected to be here, like this blue area. Blue area corresponds to the maximum of a signal, yeah. But as soon as you place one sector, you, even with a very good antenna, yeah, you are getting some non-zero energy, so-called unwanted signal overall in the stadium, yeah. And this, let's say, formulation overall in the stadium, hopefully you can see in the direct way on this representation, on this visualization, yeah. So you are spilling over to neighboring cells, and for example, your antenna, it has a certain front to back ratio, some reflections are coming. So in total here, no surprise, main three mechanisms of propagation, which is reflection, diffraction, and diffusive scattering. Everything is working together not to allow you to get maximum SNR for every particular cell. From another hand, of course, you need for capacity more cells, and this is already just giving you a feeling of a trade-off, yeah. So you need always to control how far you are from this peak on the curve. And actually, what we have attempted to do with our instrument, we have attempted using IB wave to try to define where this peak is and how many cells would be optimum for the particular stadium. When I say interference, weak isolation, all of this stuff, please also understand that when we say about weak downlink isolation, obviously we say about weak uplink isolation. As soon as you are shooting your uplink signal, you are shooting to your serving cell, you are shooting to the neighboring cell, and so on. And the same works on the other way around. So this reciprocity, always not to forget. And just to trigger a little bit your imagination to, let's say, to have this picture in mind, how the fully planned stadium would look like. This especially performed visualization with a cross section. So in this cross section, you can observe so-called, let's say, main beam, body of the main beam. So this is, of course, 3D shape antenna diagrams used, and you observe where maximum of your radio of RF energy is located. Yeah. So if you have something which is kind of catwalks or some metallic stuff which is coming inside of this blue area, of course it can trigger even more reflections, and those reflections can trigger even weaker isolation, and everything all together actually limiting our signal to noise ratio. And as I will try to explain, signal to noise ratio is the key metric and the key factor during network optimization. Yeah, and we always try to keep this SNR on maximum. As I said, when the network is overdimensioned, that maximum achievable SNR can be limited. When I say SNR, by the way, I'm mostly referring to PDCH SNR. So I hope this picture more or less clear for everyone who joined. Yeah. So by the way, later on after webinar, you can send questions. So typically we reply all of them. So I really appreciate when you attentively watching us and then sending questions. I enjoy to reply later on. Yeah, diagram, by the way, is the same. Blue color is maximum signal, red color is less signal, and you see the density of the energy here, how dense the energy in this 3D modus represented. It is really dense, and you have to be careful when you are choosing your sectorization. So, Ralph, I guess I have to mention two typical, let's say, project types we have. And one type would be, we have a stadium, guys. We are planning redesign from 4G to 5G. And this is very typical task. And this task is coming typically with antenna selection. What we do? So, for example, we know that as on the left side here represented antenna 4G. And on the right side, antenna which would be 4G and 5G capable. Yeah, so already two antennas. And if, for example, I'm experienced planner, maybe, yeah, not for sure. And I look to antenna characteristics and I read, okay, my pattern 49, 48 here on the left side, my pattern main lobe 52, 56, gain 11, gain 10. So what could I say? I say, yeah, guys, maybe you can simply exchange one antenna to another and there will be no problem because I do not see this is really critical. Perhaps 1 decibel of front to back ratio can have some impact. And exactly for this, to try to reply not just like I have just replied, like, okay, just use the antenna, we apply modeling. Yeah, so we do simulation for antenna 1 and antenna 2. And for this screen, on this screen, you can see SNR. Left side is antenna 4G, for example. Right side is antenna which would be also 5G capable. What do we observe? We observe here that we have transition from the blue colors, a lot of blue footprints you see on the left side, to a lot of green area. Is it good or bad? According to the legend I put here, it is certainly not that fantastic because you are losing your SNR just by replacing the antenna. And again, to remind, just look into the description of this antenna. At least for me, it would be not possible to say, hey guys, you will lose 5 decibel of your SNR. I would not reply this way. This is why I'm pretty happy here to be using this IBWave tool to have background. And now I can say, yes, you likely lose your SNR, and with the SNR, you likely lose your capacity, maximum achievable modulation, and so on. Yeah, that's example. And as soon as you
here you can see as well that it's really important to have a very accurate antenna pattern to run the simulations, because all these side lobes and back lobes which have the impact here, they are so important. And if you don't have that in your network design, then yeah, you miss a lot. Yeah, and that's what it's showing here. Yeah.
Exactly right, and antenna selection is a pretty critical point. Yes, and what is good part, you can experiment with another antennas, and actually you can choose another antenna, and with this antenna you can find out this distribution now about SNR distribution is getting better, and then you can prefer another antenna. Yeah, just with this, let's say, justification. And really on practice, how do we choose between two different design or the two different sectorizations? We look to the SNR distribution as here shown, for example, design version 1, design version 2. So design version 1, it would consist, prediction says above 20 decibels, it would be 5% of predicted points. Yeah, and design version 1 says it would be 38% of the predicted points above 20. Which design to prefer? Yeah, so of course, maybe if, for example, if this antenna changing is triggering you to have now less SNR, maybe it shall trigger you to think, do I need overall 5G antenna and 4G antenna together? Maybe it would be better to have just 5G dedicated antenna and not to lose on LTE side, which I prefer personally. Yeah, which I prefer.
Yeah, most of the case, catwalk installing antennas, they are all large antennas, heavy weight, and adding 2 antennas instead of 1 might not possible because of the load. Yeah.
Yeah, Ralph, good point. And this is actually the whole main reason, even if, for example, we are discussing this observation about we are losing SNR, but we are saying maybe we can think about another antenna, but we typically get the negative reply, no guys, second antenna would not be possible because of weight. You cannot go with more weight. And then again, trade-off, compromise, and this presence of compromise, it's actually the red line through all of my slides, and I think also, Ralph, through your slides. Yeah, so it's always pro and cons. I would like to highlight a little bit more about the importance of SNR. And you know, I had always this idea to try to evaluate, let's say, the cost of 1 decibel. Yeah, so perhaps it is not a triggering factor for everyone when I say, oh, we lost 4 or 5 decibels. Yeah, but if you evaluate this decibel through, for example, CQI, what if I would lose CQI, average CQI from 15 to 12 or from 11 to 7? It's clearly possible to, it's easy way to calculate that you may lose like 20% of your capacity. And to highlight again this, let's say, how close this termin of SNR and termin of capacity, they are really close. And let's check this curve for 256 QM. If we are losing SNR from 28 to 22, even with this idealistic curve, of course, it is coming from, I don't know, from science papers, yeah, you would lose 16% of capacity. So in reality, it would be more. In reality, it can be 64 QM line and different, let's say, loss on decibel. So this always to keep in mind, at least what we can keep in mind, we keep in mind SNR, this is our capacity, and we would not like to allow our design to be really, let's say, so from SNR side. Saying about SNR, we obviously have to mention how PDCH SNR can be changed under the load. And here on the slides, I will try to make some dynamic showcase here. What would happen with your footprint if you are adding the load? So I have added PDCH load between 10 and 50%. Then I return it back, yeah, and then I will try again to add the load. You see how the blue footprint is disappearing from here, yeah. The blue footprint corresponded to the maximum SNR. So of course, more users trying to receive the data, the SNR is getting worse because of weak isolation again, and dynamic of this, let's say, degradation is also very important. So you have to be on the best situation with no load situation, but also you have to choose the design which would allow very slow degradation when your load factor is increasing. So-called this, maybe this acceleration of degradation can be called, yeah. So if you are degrading slowly with this design and you are degrading with more rapidly with another design, of course you better choose the first one. Just looking to the time, I guess we need really to hurry up a little bit, right? Yeah? So I would like to show you another example what we do typically with IBWave and with stadiums. Very typical task. There is a stadium and somebody in the field defined the area where SNR was really unacceptable based on what? Based on real measurements. And then, as in this case, we are trying to reinvent azimuth and tilt, yeah, for the antenna. We are trying to perhaps to use another antenna which was available, and as in this case it was shooting to the center of the field. We are trying to redirect this antenna to try out the best possible scenario on the corner, yeah. And just ahead of this topic, I can tell you that the corner is always more difficult as a straight line because you have more reflections in there, and just from the point of architecture, it's really demanding for planar to be there also on high SNR levels, yeah. And this, you see here, it is visualized. We are trying to adjust the antenna in the way that it would give the maximum possible performance right on the corner and so on. So I guess we would continue with modulation and spectrum efficiency a little bit. So as soon as, based on two previous examples, you have defined what antenna is better, yeah. you have defined your tilt, you have defined your azimuth, you know everything about antenna, and even antenna type is selected. Now what can happen? You have come with some design, yeah, and like operator, for example, and another operator is coming and saying, hey, I have another design. Why not to take my design? It is using the same antennas, it has different sectorization. Just let's take our design, and that's it. And this is not a really rare situation when you have to choose between two different designs, and exactly for this I show this visualization. Left side.
And just to mention that the 256 gram, for example, which you can see here, that corresponds directly to the throughput you can achieve. Yeah, so it's important. Higher modulation will give you more bandwidth, let's say, yeah, more throughput at the end.
Exactly. So right, so color coding, I actually forgot to mention the blue color 256 QAM, so this is maximum spectrum efficiency. So the footprint you observe here, some of you may ask why it is changing, Victor. This is done to visualize what would happen if load comes. Yeah, so if load would be increased, of course your footprint would be smaller of maximum maximum spectral efficiency. So look into these design proposals. Left side 24 cells and right side 8 cells. What would you prefer, Ralph? Is it possible to conclude based on this information what design to choose?
I mean, it's always. I mean, as said, the throughput at the end for the customer is the most important. Yeah? So with 8 cells, you get much better, let's say, coverage with 256 gram than with the 24 cells. However, yeah, but this seems to prove the curve you have showed at the beginning. To more, in this case, it seems that less is more at the end. So less sectors will give you more better performance of the network.
Exactly right. Thanks that you're supporting me on this, delivering this message. So imagine that, as I said on the previous slide, the information I have shown you there, it's actually not enough to conclude. Some of you may say, okay, it's a very good footprint about blue color, yeah, 256 QAM. However, what happens with average user throughput, which would be observed? And what do we do? Of course, we are considering not just 2 design versions. We can consider more. Exactly for this webinar, for this showcase, we can consider design with 8 cells, 14 cells, 18 cells, and 24 cells. And same traffic profile, same stadium, same antenna type, and let's drop just 10,000 users for each one, for each of these proposals. Yeah, and this right after we have dropped users there, we can observe our average user throughput, which would be achieved with this particular design. And already this component, which is average user throughput, this is already, it was missing for the previous slide. Now we see it, and based on this, we can at least we can try to make conclusions. And again, we can try to see this trade-off. What kind of trade-off? You see, we make a transition, for example, just a virtual experiment. We have made 8 cells, and now we have 24. So we do 300% more cells. We are multiplied by 3, yeah, and we increase on average user throughput from 223 kilobits per second to 400 kilobits per second. Don't worry, it's low throughput, but the traffic profile is really heavy here. It's just for comparison, yeah. Here selected. So what do you observe? You have gained 2 times on throughput, but you have to invest 3 times in your hardware. You have to pay more for licenses and so on. What if we compare with 14 cells design? Yeah, so for 14 cells design delivers 300 kilobits with the same amount of users, same traffic profile, and 18 cell design, most interestingly, can deliver 400 kilobits per second as well. And here, if you have got the initial message about the curve, just send the plus in the chat. I will be glad to see it, because this is exactly the peak and the situation which we described in the beginning. So what happens in fact? So transition from 18 to 24 cells may trigger certain degradation even of a throughput, or at least no gain in throughput. Yeah, and this is already a sign to stop and think, what if 18 cells would be deployed? do we do all good with 24 cells? That's the main message here. And using these calculations based on our instrument, which is IBWave again, we can deliver this practical curve, which would be a good, let's say, simulation proof. It can be, let's say, reality proof when you really build 4 stadiums with different designs. It will be proof from reality. But from modeling perspective, there is a proof of the character of this curve here represented. And this is exactly where, you know, I'm located between 8 and 14. Okay, I'm located between 18 and 24. Or by chance, I have deployed 36 cells. Where am I located now? Am I doing good? Maybe not. Maybe I have already passed the optimum point of 18 cells, and actually my SNR is already limited. This discussion I'm trying to trigger, and let's say if you have also your opinions, ideas about this, please send after.
Ralph. At the end, the optimum point is the most cost-effective design. Yeah. Otherwise, you spend a lot of money for infrastructure, which does not give you a benefit. Yeah.
Exactly, and I will have to. I think I will better repeat it. So this character is more, let's say, is more often for 1.8, 2.1, 2.6. This FR1 bands. Yeah, for millimeter wave, this peak would be really hard to achieve. We can talk about it. But Ralph, as you mentioned in your slides, you have shown augmented reality scenario, which is not the case nowadays in the stadium. But for augmented reality, I think you will need really, some people say real 5G. Real 5G, this is millimeter wave, guys. So this is how we joke here. So, and 3 slides about how you set up the traffic. The traffic model, you can set up file downloading, how many pieces of files, how many phone calls, emails. This is settable. As I said, the traffic profile was really heavy in 1 hour. Each user was about to send almost 200 megabytes. It's really heavy, and exactly this traffic model was used on the previous slide just to trigger your attention. And then it is possible, yes, Ralph, it is possible in IBWave to set the amount of users separately for the different stages, yeah, for different levels of the tribunes. And this is a good opportunity because at least for this stadium, we have used such a software feature for investigating what is achievable on tribunes from user throughput perspective. And quite interestingly, you see this is a legend from blue colors, and the really heavy blue is representing the maximum average throughput. Yeah, it's very interestingly how it works. Yeah, we observe this blue area on the corners. Obviously, our antenna is shooting, the same antenna is shooting, but the amount of people who would be located there just because of architecture, they are less, yeah, and you are gaining a little bit on average throughput. And we have done even one very interesting scenario from our point of view, what if scenario, we call it. What if users, let's say 5,000 users would be drifting between tribunes? What happens, for example, end of the game when everybody decided to go from upper tribune to the lower tribune, yeah, for 5,000 users just drifting down, yeah, and then what would happen with your average throughput? So this more for showcasing. However, it also can reply a question from marketing: what kind of throughput I would be expecting beginning of the game, middle of the game, ending of the game, and so on. Ralph, I do have 5 minutes more, or do I not? I do.
Yes, I think yes, probably yes.
I hope I do.
So not too many questions yet in the question box. If you have questions, you can just put it there already.
Yeah, of course, I would appreciate questions or after or right away. Another arena I would like to show, the first one was about football, now it would be about hockey. And from my point of view, hockey arenas even more complicated for planning. Why? Because of very, let's say, dense scenario, and it's typically closed. There are more reflections. Architecture can be challenging. Like here, architecture for this arena, it is so performed that tribunes on one side is much wider as tribunes on another side. Yeah, and simply there is no chance from architectural point of view here to use the same antenna, for example, wide one, yeah, this antenna would be suboptimal on one of the sides. And here you have to invent some, let's say, approaches which is not maybe used on every corner. So I would call it a synthetic way of footprint creation, yeah. And under synthetic way of footprint creation, I call when we combine simulcast way 4 antennas here, and we are trying to choose another area where another 2 antennas would cover similar amount of users, yeah. And then it would be balanced on load between this upper tribune and lower tribune, and then we choose another areas, again trying to be balanced. And here, as you see, we apply really narrow antennas. This is about 30 degrees, yeah. And we are trying to construct a desired footprint using narrow antennas, let's say in this synthetic way. So we can compare it maybe with Lego, yeah, principle. So we are trying to construct desired footprint. I have heard even on Mobile World Congress that people are trying to make let's say, custom designed antennas, which would be in line with architecture. This is also interesting direction, but we are not using this so for this stadium. So you see, we are adding this footprints, trying to be balanced on the load factor, yeah, and we are trying to handle this antenna with minimalistic SNR. And again, as soon as we get final SNR picture, for this stadium, we have developed 2 different designs. The left side is for 8 cells, the right side is for 10 cells. SNR here in the middle, so you may observe on visualization what would happen if load factor is increasing. And would it be beneficial to have maybe 8 cells, and 8 cells would be enough? Actually, from this selection, I would prefer the left design, because total area of degraded SNR is a little bit more with 10 cells. And this is again repeating story. Sometimes architecture limits you to have more cells, even if you have calculated it through the, let's say, XLS calculator. And I find it pretty interesting for IBWay that there is opportunity to have combination between traffic profile setting and SNR calculation. It gives you advantage what typical calculation in XLS cannot give. For example, typically when you try to calculate capacity with XLS calculator, you can take this coefficient which would reflect degradation of SNR. Problem is, this curve we have shown, this is not the same between different stadiums, yeah. So for every stadium you have to invent what would happen. Ralph, I guess I would mention EMF, and then I would prepare handover for you. Would you mind?
Right. I think because we are close to the end, so
yeah. Just have a look. This example is to visualize for you EMF calculation. So regulation current, which is also here valid in Germany, this is 61 volt per meter, yeah. But just to visualize this maximum, I have to set really ridiculous power level like 600 watts, which is typically not achievable. I mean, this is just to showcase that it's possible to visualize the body where you would not be allowed.
Yeah, because typically
better not to go there. Better not to go there.
Not close to the antenna, but in some cases maybe you are close on the catwalk walking there if you have to do some maintenance. But maybe antennas are close, like the underseat antennas and things like that, where you need to calculate safety distance. Yeah? And this is important, yeah, because we want to have a safe stadium at the end for all the spectators. Yeah? And this can be calculated, yes.
Yeah, and exactly for this reason we have made this model really detailed in detailed way, because persons and some people can be located on the catwalks, and we would like really to check if some, let's say, impossible density of RF energy would be there, and we have checked. And also we have performed the same analysis for the stadium, yeah. And we have checked where our EMF would be on maximum. And again, as I said, typically we plan in the way that we are far away from this border 61. We are far away from 10. So this is just done here for showcase. Ralph, the last statement I would make a handover to you. All of the slides I have shown to you. The main idea is to have a good fundament for all further optimizations, which obviously can be done on the stadium. So, for example, we can compare that we are building the fundament for some house, and house will be built later on by another people. Yeah, because as I said in the beginning, if the RF design is not performed pretty well on the maximum, on this peak, if it is not performed on the peak, it is almost impossible after to achieve, for example, features like high order modulations to be working. They will not work because SNR would not allow. Ralph, thanks a lot. Thanks a lot on the bridge for attention. I would pass back to you, Ralph.
Thanks, Victor. Great presentation. Thank you very much. Because we are very close to the hour, yeah, I will just quickly share my screen to talk a little bit about indoor-outdoor. So let's call it bridging the gap between indoor and outdoor wireless. As you can see, there's some outdoor world as well, which could provide coverage inside where you don't want it. And you need to design that proper. What we have is a solution which we call IBWave Reach. It's a macro planning tool, and I just selected the Frankfurt Stadium because I'm living very close to it, and it's European Championship, so that's why I choose this one. The tool allows you really to import digital terrain data, clutter data, building polygons very, very easily to place your macro network sites close to the stadium and then run the simulations over there. Yeah, so it's really an easy tool to get the an idea of how much signal will penetrate inside your stadium, and then you would run the simulations, interference simulations, and the areas where you have the overlapping and all that stuff. Just quickly, you can export that as well to Google Earth, because I think you can see it a little bit better here. So when I do not have my coverage activated here, yeah, you can see inside the stadium, yeah, you see the code, and if you activate, run your simulations, you see there's some signal inside the stadium. So you need to take care of that coverage as well. And on the other way, the leakage from the indoor system to the outdoor. You can analyze both. We do not have time today to cover that. If there's an interest on your side, let us know. We can make a separate webinar maybe on that topic. Maybe the last point I would like to show as well is in IBWave design, the stencil library saves a lot of time for you. When you do 3D modeling, all the trees, as I said, all the cars, buses, trains, and things like that, you can simply create templates for catwalks, for anything you have in your stadium design, and just drag and drop that on a floor plan, yeah, to run at the end, to run your predictions in a 3D model. And someone was asking about, do we have coverage here as well for Wi-Fi design? So let me quickly activate the Wi-Fi. I need to activate it. It's not activated.
Ralph, I see these models of the cars. Would you say that it's default library? Yeah, so I could take it from library or not?
That's default library. So just to show a Wi-Fi design, because there was one question from the audience, do we do Wi-Fi design? So that's a Wi-Fi design. I don't know, hundreds of antennas there, and you can simply simulate the indoor as well as the outdoor. And each of these, like if you look at the train, it will have an impact. It's out of metal, yeah, so it has an impact on your signals, yeah. And it's drag and drop of components from our stencil library, which you can see over there. You know, you just drag and drop these components there, and it makes life really, really easy and very accurate when you model your stadium and you run the simulations. Okay, so that should conclude our presentation today, because I think it's we're already at the end. So maybe a few words about training. Daniel, do you want to jump in here?
Sure. Well, first of all, thanks for the presentation. It was great, Ralph and Victor. So I just want to take 1 minute to talk about the special promotions. So we have at IBWave training and certifications available, and now you can take advantage of 15% off on all online certifications, courses, and modules. So if you use the code Stadium 2024 and scan the QR code. That's where you can apply it for any course or certification that you select. And as Ralph mentioned before, we have also one specific on Stadium, so you can take a look, choose whatever you like. Also, you can purchase our products online. This is just for some of them, but you can head to store.ibwave.com to purchase products online, or contact sales.ibwave.com for more questions, or if you want to request a private demo or pricing. So with that, I think we can take maybe 5-10 more minutes, Ralph, for questions. If you can maybe leave the slide on for 2 minutes, so our attendees have the time to scan the code.
Thanks, Daniel. So I do not see any questions in the chat here. I mean, what I would like to see is getting feedback from you guys as well about, I mean, we talked about millimeter 5G upgrades. If you talk about millimeter wave band, there's a lot of experience in the US, probably because they're already millimeter wave band stadiums deployed. We are just starting here in Europe with that. And getting the experience maybe from your side and maybe support you as well, yeah, on proper dimensioning and design of stadiums. Yeah, get in touch with us and we'll help you.
So, Ralph, I don't know if you see, sorry, I don't know if you see all the questions, but I can see about 15 maybe questions in the chat.
Okay, I can't see all of them. No, let me see.
If you open the questions box.
Yes, question box. Sorry, there was a tick box show answered questions.
Yes. And there are maybe 10 more below.
Yeah, Ralph, just read it if you see it, because I still trying to make a visible way.
I'm sorry, but I can't see the questions here. It's only one question which is there in my box.
All right, I can maybe read some to you.
Yes.
There's one from Christian who's asking, there can be other events than sport events, for example, concerts or other mass events can be held in stadiums. How can you provide sufficient SANR for user data throughput in the middle of the field when users can locate there as well?
Middle of the field, Daniel, here we mean some stadium again, yeah? So it would be a public viewing event or something, but middle of the stadium.
Yeah, you mentioned the Metallica concert, Victor. So if you're in the middle of the concert and in the bowl, yeah. So how can you make sure this?
Yeah. First of all, if there were no dedicated sectors installed for the middle area, it is really nothing to expect from the performance perspective. And as in this example I have shown to you, sometimes you are not even able to be connected, and this situation can be, for example, for 3 minutes, for 5 minutes, and hardly possible to see right after all in the stats, but you will be not able even to connect. So PDCCA channel can be busy, yeah, so to say. But there is no quick reply. First of all, you need to be sure about your planning a ref design for the area, for the target area. If you have it planned, yeah, and you have predicted a SNR, you can experiment what happens with this SNR under the load. And exactly as I hope I have shown, and I hope I deliver this message, you can not only calculate once your SNR picture, you can calculate it in an iterational manner, and through this iteration you may see how quickly you would degrade on SNR if load is coming. This is what I would recommend to perform. And mass event, actually my observation is pretty interesting point. You know, when I was in the stadium, I look to the people, I do not see everyone is using the device. But what happens nowadays? You don't even need to use your device. It's enough if you came there with your device. It's already enough because applications is doing connections on not in synchronization with what you do, first of all, and secondly, the iPhone can start sending photos to the server, to the cloud, just the photos from yesterday, yeah, and it's already unbiased to the human behavior. And our observation is, even if there is a mass event like a concert of Metallica, people came there, and even without any, let's say, heavy actions on the phone, the network can be just loaded by the fact of presence if there was no dedicated design for the area. Which means, Ralph, your examples like augmented reality, it is of course a little bit music, future music, yeah, as we say, because for that you will need even more, let's say, another level of planning, and of course millimeter wave will be part of it, I believe, for augmented reality. Daniel, anything else? We are ready to reply.
Yes, there are many questions. Keep coming up. There's one about calibration. What is the importance of calibration, and what to do if we don't have survey data?
Yeah, pretty good. Yes, I would vote. This question would be my favorite. Calibration. Where to start? First of all, calibration, if it is a must, if you are serious about your design, yeah, it is a must, because even very detailed model cannot deliver everything really precisely. But the good part, if you really do calibration, and for calibration, in fact, you need a couple of rounds with the scanner, yeah, and then you load this data in IBWave, and you see, and you can calibrate the model, and all your next predictions, even for another stadiums, can become really better. But as I noticed in the question, for example, you have no calibrated data. I would say there is opportunity to have at least minimalistic calibration. For example, with some, let's say, easy applications, it is possible to get the level exactly in this point, and to make such a points in different parts of the stadium, and then to load those points in IBWave, and still to try to adjust the model based on that. So I guess for everyone now is available applications which show you the level, yeah. And
but you
need
survey data. You need measurements, yeah.
Yeah.
Oh,
Measurements anyway needed, and if you're serious.
The problem is calibration. I see is always that an empty stadium behaves different than a full stadium, yeah? And calibration for a stadium, it's more complex. Yeah? You can run a drone. You can use a drone and do measurements in the stadium easily and collect as many measurements as you want, but you can't do that when the stadium is full. Yeah? So there are limitations. Yeah.
But let's say 5 stars out of 5 for this question about calibration. It's a good topic. Actually, I forgot to mention it even during the slides. Anything else, Daniel? Please give us more.
Yes, so there is quite a lot of questions about the presentation. If we're going to share it after the session, and I can respond to this, yes, we'll share the presentation with the recording afterwards. So you probably receive it within a day or two. Next question there is about, can I get more details and use of IBWave on the uplink budget design planning? Oh, this is probably for you.
Uplink, there are metrics related to uplink. Ralph, I think you know even better than I.
Yes. So we support uplink and downlink, both directions for the calculations. Yes.
There is possible to set the curve for uplink. For example, SNR curve can be set for uplink. I would say our experience in STF here, this stage, we do not approach for every stadium. The maximum what we have for now achieved, for example, propagation model verification. So this calibration we have performed, yeah. The next logical step would be to verify also uplink story. And this is still in our plan, and this is also a good vector for us to continue. This is, but tool, Ralph, please comment if tool allows. I guess you know it better.
Yeah, sure. The tool allows uplink and downlink simulations. So yes, sure, we can do.
All right. There is one question about the EFM compliance. So what is EFM compliance criteria limitation your stadium design? In the US, we applied 12 inches for compliance distance. 12 inches equals 0.3 meters.
It's distance here is a function. Distance is a function of density of electromagnetic field. Yeah. So what is defined? Defined is density of this electromagnetic field. And as I said, for at least for European part of the globe, it would be 61 volt per meter or 10 watt per square meter. Yeah. And this metric,
this is parameter you can easily adjust. So it's not 61. If you say for stadiums, I have a different, more strict value, you just change that. And based on the radiated power of the antennas, it will calculate the safety distance. So that's the function. Yeah. So you need the frequency, you need the radiated power, and all that will automatically calculate by the tool.
Mhm.
All right. Well, we are 10 minutes over. I think we can take maybe 2-3 more questions, but we'll get back to you by email for those that we won't be able to answer today. So there's a questions. Can we trust a solution with IBWave to reduce the number of APs? And then there is a follow-up question. What is the number of users considered on the mobile dimensioning for 40,000 to 50,000 devices?
So Daniel, could you please repeat the first part of the question? I didn't.
Yes.
Can we trust a solution with IBWave to reduce the number of APs?
Yes, APs or small cells or antennas. Yeah.
Yeah.
Yes.
So first of all, I guess under assumption that the model is detailed, it is prepared accurately, the propagation model is calibrated. I see very good relevant level of, let's say, accuracy when we compare. In some projects, we compare how accurately it is predicted versus measurements. Yeah, and there is even function when you can compare CDF PDF distribution between predicted and measured. And I can tell you that the level of correlation is very high. Under assumption, if the model was calibrated, if the model is calibrated, you really get really good level of correlation. And Ralph, I guess we have discussed it for one project. This curve, yeah, so then it can be 2 to 3% delta, but not more. Challenging is
accuracy depends on the model. Yeah, if you have a very accurate model, then the result will be accurate, as we are using fast ray tracing and consider all the parameters. So yeah, as Victor said, yes, if you model it accurate, you will get accurate results.
So there's another interesting question. Have you validated any of your implemented stadium designs? And what was the result or difference of both coverage and quality SNR from the design versus the file from any walk test / RX measurement tools?
Mm-hmm. I would reply this way. We have used measurements for comparison, and we have adjusted the propagation model for one of the stadiums. And after adjustment, we have performed iterational new modeling, and exactly this project was about 4G to 5G upgrades. Yeah, and this design we expect now to be developed. Yeah, expect to be deployed. So I cannot say for this second that it is deployed and we see the result. However, if you ask me, I would not go and deploy without verification with prediction instrument, of course.
Yes, I think at the beginning I showed two examples, two testimonials from our customers from stadium design, and they proved that the predictions done with IBWave are accurate and at the end, I mean, increases the performance of the network and save time and cost deploying the network.
What is I maybe share our also, let's say, lessons learned. It is maybe, yeah, looks easy to deploy the design which is already given, but on practice, if you give, for example, the tilt and azimuth, this tilt and azimuth has to be deployed in the field. And what is really tricky part to check if exactly this tilt and exactly this azimuth was deployed. It is quite, let's say, not easy way for checking this. So you see the antenna, but you are not sure about. This is why the quality of such, let's say, company who is doing this service must be on the really high level, because you need to be sure plus minus 2 degrees you may lose your SNR and you may degrade. This is why stadium is stadium. This is not walking in the park.
Yes, and that's why at the end it's important that you have an as-built documentation. So you go out, you check the installation, you take pictures from installation, you modify your design network according to what's really built. So, and then you can run again some simulations and compare that. Yeah? Because as Victor said, you can design it, but the installers will do something different at the end. That's important. Yeah, we want to have a digital twin of the network in our tool, because then we can do the simulations proper, and we have all the documentation we need to maintain the network.
And for example, in this hockey arena, I have shown to you, it would be very big passive part, and as soon as you have passive part, passive and let's say distribution, you can, let's say, face with problems of PIM, and PIM can be also external PIM, and those problems has to be detected before even first attempt of fine-tuning of the network, before even first measurements. VSWR, PIM measurements has to be there. So if everything is performed, it's pretty likely the network will be good functioning.
All right. So yes,
but don't hesitate to contact us if there are any questions. Get in touch with us. If you want to have a private demo, just let us know. We are ready.
For sure.
Daniel, I have seen one question about antenna patterns, 2D and 3D. I find it very interesting. Do you want to reply this one? Have you seen it?
I mean, standard antenna patterns are like 2D. Let's say you have horizontal, you have a vertical one, and but this is not very accurate if you talk about accurate antenna patterns with side lobes and back lobes. So if it's a 3D antenna pattern, you have a measured antenna patterns, let's say in a chamber everywhere. Yeah, so it's very, very accurate, and your predictions will be accurate. So if possible, only look for antennas which are really 3D antenna patterns to increase your accuracy.
All right.
I see so technical questions. I'm so happy to see it. Some of them, for example, from Vivekanand, I think it is even big text, which
that's great. We will answer all the questions after the
simply
session.
Our format would not allow. From Ariel Marquez, it was attempt to reply. Also, very nice question. I find very technical ones. Thank you guys, much appreciated. Just amazing. Will you provide a certificate of participation for this webinar? I like it.
That's a good one. Absolutely.
I perceive it as a compliment for you. That's nice.
Yes, for this, I think we can provide you with acknowledgement of participation. That's for sure.
How can we do capacity output map based on uplink traffic demand? Wow, that is nice. That is nice. What would you say would be typical user load profile for Stadium? Niall Norgard, typical traffic profile. Yeah, that's a question for marketing department. Yeah, but our recommendation is to have statistics on your site. Statistics works for you, for the planner, and a good planner before you even start, he has all the statistics for all of the games, events in the last 10 years. I'm just joking. In the last half of the year,
we have predefined subscriber profiles in our tool, but as Victor said, I mean, it's every stadium's different, and every country is different. Yeah, and so it's really important that you play with these subscriber profiles as well, and you have some buffer, yeah, to make sure that you provide enough capacity for your network. But it's all, at the end, you need to have your local subscriber profiles you have.
Just for a second, Ralph, what would be the ideal open of the antenna for stadium designs? Would it be a function of the number of sectors of the project or function of SNR in the project? Very deep question also. Ideal antenna. As I mentioned, and I like actually this idea, ideal antenna does not exist. Every stadium is different, yeah, and it can be only found by chance, but this antenna fits architecture of this stadium. It does not happen on every stadium. I would say it happens almost in no, not possible that this would happen. So always antenna is suboptimal. And interesting enough, I found out that some folks I have seen, they decided, what if we design antennas for this particular stadium architecture? This was an interesting thought, yeah. And antenna design, this is also not a, I would say it's not a rocket science. You place your elements in the antenna. You can actually design antenna which would be 30, 60, 25, 80, whatever you want, and with a very sharp edge. And ideal antenna from main vendors would not be named by me, at least, would not be named. So it is always trade-off. What if I try to use this vendor for this stadium?
Victor, you could do it the other way around as well. You could simulate different antenna patterns in IV Wave and say, okay, I need vendor X. I need this type of antenna pattern that will fit best for my stadium. You could do it the other way around, yeah? Just playing around with different antenna patterns and find the best one and go to the OEM and say, please create that antenna for me. Yeah,
I see, guys, the question about one company is planning in Revit, and I lost this question. It was just here, so it would be also interesting to reply later on.
Well, Revit is on the roadmap. Will be released once it's fit for real stadium design.
One tricky question is about Monte Carlo simulations. Here we assume all of the users would behave simultaneously. Yeah, that's a current story. However, it's a worst case scenario, and yes, for comparison, it would be enough for the current situation. As I said, the current benefit through IBWave, it is for now possible to combine XLS calculator of capacity and realistic, more or less realistic SNR picture, which could be again achieved through calibration of the model. Yeah, and this through the traffic profile modeling in one tool, and you get your curve. And you are hunting this peak, because if you are far away from the peak, too many or too low, it's not the best situation from a RF perspective. But again, for comparison, you assume this heavy traffic profile, but all of the users is attempting to shoot in the same time. Of course, this is unrealistic situation. However, for comparison, it can be enough. Not for, let's say, direct check. I would say so. What is the difference of your design accuracy if you use 2D antenna patterns compared to 3D? I never use 2D. I never use 2D. I don't know what to say. I don't know. You guys, you allow 3D, we use 3D. That's it.
Yes, yes.
Excellent analysis.
That's the advantage of our solution, that you can really import high accurate antenna patterns. So yeah, for projects like that, stadium design, I think it's mandatory really to go for highest accuracy.
Are you aware of Galtronics patented multi-beam technology that offers performance comparable, maybe lens antennas or so? I'm not aware, but interesting question from Robert McKeever. Really interesting.
Yes, yes. So we do have Galtronics antennas as well in our database, as all the other major vendors. We work together with all of them, and beamforming antennas, that's something we are using as well in our database. So if you want to do simulations on beamforming, that's possible. Yeah.
Let's say not a question, but a comment. It's giving us credits, Ralph. Excellent analysis. It would be nice if IBWave implement the animation and graphic analysis using AI technology. Ralph, do you do with NVIDIA or something?
AI. Sure, that's coming. I mean, IBWave is based in Montreal in Canada. That's the big hub that's the new Silicon Valley for AI augmented reality, and we are part. We belong to Corning Optical Communications. So with Corning and IBWave, we invest a lot in AI and machine learning, and that you will see on our future roadmap. AI, machine learning. That's for sure. It's coming. Yeah.
Of the inclines, yeah, some questions I would not react so quickly, because my reply would be too, let's say, simplified. Better to take it for deep consideration and probably reply through the email, which we typically do, Ralph, I guess. Yeah. So we do not leave unanswered questions, at least on my memory, last 3 webinars. Yeah. So some of them are.
answer on all the questions, right?
Exactly.
Can we get IBWave file? Can email the presentation slides using under the seat? Under the seat antenna, Ralph, you have shown this is very interesting approach. But Ralph, this augmented reality, it requires 10, 20 more traffic profile in comparison with current. And even, for example, for now, you are going to the just a pop-up event like a concert, and you cannot even be connected. So imagine that we need new solutions for such augmented reality. It would not be possible to provide
that's
with the current.
Why I said we need to be future-proof, because the future is like that. I believe that is the future, and yeah, we need to support that. We are doing it. So,
Ralph, a question from Kirk Kohn. We do most of our design within Revit. Is IBWave going to allow the import of this type of file? +1 for this question.
Yes, as said already, it's on the roadmap. There's no release date for that, but yeah, be patient. It will come. We will only release features if they are 100% working for any kind of project, specifically for these more complex ones, not just, let's say, a square building importing. That's easy. We can do that, but it should work for any type of import, and so that the customer can really use it at the end. And we will release it, yes.
For the dynamic prediction that Victor shared during the webinar, is this something available in IBWave, or is it just many simulations combined into one video? For this webinar, it was combined. Is multi-beam antennas better compared to beamforming for stadiums? Multi-beam better to beamforming? It's interesting to think, because with multi beams, there is opportunity to use, for example, lens antenna with many beams. This can work for some cases.
Yes, I mean, from the simulation, you can in IBWave you can switch on beam number 1 and beam number 20. You can switch on and off and run simulations which beams you should really activate or not. But at the end, it's done by the system. You will not probably program your antenna and say, okay, you have to radiate with that beam and that beam. Yeah? But you can run the simulations. That's important, because you know which beam will have which impact in which area.
Does IBWave factor in multipass when it simulates SNR? So I guess SNR, Ralph, correct me if I'm wrong, SNR is calculated based on multi-beam, multi-pass propagation.
Yes.
If AI comes, does this resolve 3D modeling time?
If AI comes, does it resolve 3D modeling time? I mean, 3D modeling, the best is you just import a 3D model and it's there. That would be just one-click import. That's what we would try to achieve here. But AI, I think maybe the future will be like you ask ChatGPT, please model me that building. Just here's the file, and then it will just do it for you, if that is AI. Yes, it will. AI will change a lot. Machine learning will change a lot. Yes.
I would be happy to join another webinar covering IBWave Reach and its use of accurate modeling inside office buildings, stadiums, and so on. So Ralph, it's your call.
As more feedback we get, perfect.
Uplink budget design. Uplink questions about uplink, also high level of deep dive for technology scene. You both mentioned the importance of antenna patterns, performance. This is again about antennas. Super. This stack is amazing, guys. I think we already running out of energy replying in the clever way. Yeah, time needed to be specific and precise answering this.
Yeah, I think we can wrap it up, Victor. We'll get back to you as mentioned before. We are 30 minutes over, but thanks a lot, Victor, Ralph. It was excellent. Thanks everyone for your participation, your questions, excellent questions, and yes, we'll see you at the next one. Thanks a lot.
Yes, and don't miss the next football match starting soon today. So we're just ready before that starts, so it's perfect.
Yes.
Grab a beer and enjoy.
Yeah, as we see, we have football vibes here in Europe. Yeah, so Ralph, good luck for the team.
Thank you.
Thank you.
Much
Thank
appreciated,
everyone for
guys, on the
joining
bridge. Unfortunately, I cannot hear from you, but I'm looking forward to reply for all of these questions. Thanks a lot. Much appreciated.
Thank you. Have a nice day. Bye-bye.
Thank you. Bye-bye.